Anytime, anywhere, anyway.
Yeah.
That's pretty much the expectation now, isn't it? How we access information, how we connect.
It really is.
And honestly, the fact that you're listening to this deep dive right now, that itself is proof of how much telecommunications tech has reshaped everything.
Absolutely.
So today, we're going to, well, cut through the complexity a bit. We're taking a deep dive into telecommunications, the internet, wireless tech.
Yeah, the whole ecosystem.
Exactly. And we're drawing our insights straight from a foundational source. Laudon and Laudon's 17th edition of Management Information Systems.
Right. And our goal here, it's pretty straightforward. We're not just here to list definitions.
Yeah.
We want to really unpack the key parts of these huge networks, the technologies that make them work. We want to show you how they're built, sure, but also point out some, surprising strategic angles and critical insights.
Things that give you an edge.
Exactly, an edge in understanding and, importantly, leveraging this digital future, especially, for anyone aiming for a career in information systems or IT service management.
Okay, so let's unpack this. Where do we start? Maybe with the big trends, like convergence.
Oh, definitely. Convergence is huge.
Most of us, grew up with separate things. A landline phone, cable TV, radio, they were all in their own boxes.
Completely separate services.
But those lines are, well, they're not just blurring anymore, are they? They're practically disappearing as everything piles onto the internet.
Vanishing, yeah. It's getting really hard to tell where one service stops and another starts.
It's all just data.
And this convergence, it's way more than just like a convenience for us at home.
Right.
It's a fundamental strategic shift.
Yeah.
And it's really being pushed by high-speed broadband becoming available almost everywhere.
So for businesses,
For businesses, it completely redefines how they operate, their supply chains, how they deliver services, everything. Understanding this unified digital infrastructure is, well, it's absolutely crucial for anyone in IT service management.
because you're not just managing separate systems anymore.
Not at all. You're orchestrating this whole interconnected digital world, this ecosystem.
Okay, so this ecosystem, let's get down to basics. What are the actual building blocks? What is a computer network really at its heart?
Good question. We often just take it for granted.
Yeah, things like network interface cards, NECs, right? Network operating systems, the NOS, and then hubs, switches, routers. We hear the terms.
But understanding what they do shows you the genius behind it all.
How does it work?
Well, what's really fascinating is how these seemingly simple parts let networks just grow exponentially.
Scale up.
Exactly. You can start small, maybe like a home network setup. But that same basic idea, that infrastructure, lets it scale up to a massive global company with thousands of devices and servers.
Wow, and managing that complexity.
That's where newer approaches come in, like software-defined networking or SDN.
Okay, SDN. What's
Yeah.
the core idea there?
Think of it as separating the network's brain from its muscles, instead of tweaking every single router and switch by hand.
Which must be a nightmare at scale.
Oh, it can be. SDN lets administrators program the whole network from a central point using software. They can reroute traffic on the fly, optimize performance automatically based on what's needed right then.
So it's much more agile.
Massively. It's not just about saving time. It's a whole different way of thinking about network management, a real paradigm shift.
That move from hardware focus to software control.
Yeah.
Yeah, that's huge. Okay, so let's get into the engine room now. You mentioned 3 key technologies powering all this.
Absolutely. Foundational stuff. First, client-server computing.
Right.
This model really changed everything, including the internet itself. We moved from those big old mainframe systems.
Giant computer doing everything.
Exactly. To a distributed setup. You have smaller, specialized servers handling tasks for many clients, our computers, phones.
Makes sense.
And this setup is fantastic for companies that are always growing or swapping out hardware. It gives you flexibility, resilience, really crucial in today's world.
Okay, so client server is number 1. What's next?
Next, and this is truly fundamental, packet switching.
Packet switching. Heard the term, but break it down.
Okay, imagine you need to send a huge, detailed report across the country, like a massive document.
Right.
Instead of trying to shove the whole thing through the wires at once, which could easily fail if there's a tiny blip.
Yeah, like a clog in the pipe.
Kind of. Packet switching breaks that huge report into tiny, manageable pieces. Packets.
Little chunks.
Exactly. Think of it like sending 1,000 postcards instead of one giant, fragile poster.
Okay.
Each postcard, each packet, can take a different route through the network if it needs to, finding the quickest path available at that moment. Then, when they all arrive,
They get put back together.
perfectly, in the right order.
Yeah.
And this happens so incredibly fast, so efficiently, you don't even notice it when you're streaming a movie or downloading something.
It just feels smooth.
But underneath, it's this constant, complex dance of packets finding their way. And crucially, there's error checking built in to make sure the data arrives intact.
So that's what makes the internet reliable and affordable.
It's a huge part of it, yeah. It allows data to flow constantly, even across these massive shared networks. Very robust.
Okay, client-server, packet switching. What's the third key?
The third is TCP/IP and connectivity.
Right, TCP/IP, the language of the internet.
That's a great way to put it. Transmission Control Protocol Internet Protocol. How does your email find the right person out of billions online?
TCP/IP.
TCP/IP. Its biggest strength, its most important benefit, is that it lets any two computers talk to each other. Doesn't matter if one's a Mac, one's a PC, different software, different hardware.
It doesn't care.
It doesn't care. It provides these standard rules, these protocols that basically ignore the specific machine details.
So for businesses,
Huge cost savings. They can create web interfaces to pull data from different, maybe older databases without having to physically merge all that data into one giant new system.
avoiding massive, expensive integration projects.
Exactly. It's the ultimate layer for making things work together. Interoperability.
So TCP/IP is like the universal translator for the digital world.
Got it. That leads nicely into thinking about network scope, how big these networks are, local versus global.
Right.
And maybe just a quick refresher, digital versus analog signals.
Worth mentioning, yeah.
Digital's the computer language, right? Zeros and ones. Crisp. Analog is more like the continuous wave, like old phone lines.
That's right.
And the modem, that little box that's the translator between those two.
The crucial translator, yep, modulator to modulator.
Okay, so building on that, different network sizes.
Yeah, defined mostly by how far they reach. You've got the local area network, the LAN. That's everywhere.
Like in our homes, offices.
Exactly. Could be just 2 computers or thousands across a whole campus. The source even mentions network-enabled pianos.
Seriously.
And then to connect further out, LANs usually link into bigger networks, wide area networks, WANs, or maybe metropolitan area networks, MNs for cities.
And these aren't limited by distance. Not really. They use a whole mix of technologies, fiber, satellites, you name it, to connect locations far apart. Lets a global business act like one single entity.
What about smaller businesses? Is there an alternative?
Yeah, for small setups, peer-to-peer networks can be a good option, cheaper than client-server. Basically, all computers are equal. They share resources directly.
Okay. And how does the data actually travel, the transmission media?
It's usually a mix, right? A complex path. Your data might go over old school twisted pair wires for a bit, then jump onto super fast fiber optic cable, maybe bounce off a microwave tower or even a satellite.
Oh, seamlessly, hope.
Appearing as one clear channel to you, yeah. And when we talk speed, we often hear bandwidth, bits per second, BPS.
It's always better, right?
Generally, yes. But it's also about how efficiently those bits move. Measured in hertz sometimes, which gets at the capacity of the channel. For a business, the real question isn't just the raw number, it's how that speed translates into, good application performance, happy users, and ultimately a competitive edge.
So there's no single right network. It really depends on what the organization needs, its strategy.
Absolutely. One size definitely does not fit all.
And things are changing fast. New network services promising much higher speeds are coming.
Constantly. It's going to impact everyone.
Which brings us squarely to the internet. We use it every day, but what is it, fundamentally?
Its history is pretty cool, actually. Started back in '69 for the U.S. military.
Right, ARPANET.
Yeah. And the core idea, internetworking, just connecting different networks together, was revolutionary, letting data flow between them.
So what isn't the internet? That might be easier.
Good point. There's no single central computer running it all, no single owner, no single control point, no single entry door, no single type of thing you do on it.
It's decentralized.
Hugely. It's basically this massive global collection of networks, all talking the same language, TCP/IP over wires and wireless connections.
And how do we connect?
Individuals, small businesses, usually through an internet service provider, an ISP.
Like Comcast, AT&T.
Right. Using tech like DSL over phone lines or cable internet, bigger places like universities or big companies, they often have dedicated high-speed connections like T1 lines, more robust.
Okay, so we're connected. How do we find anything? Let's talk internet addressing and architecture.
Right. Every single thing connected to the internet, your computer. A website server has a unique address. An internet protocol address or IP address.
With a long string of numbers.
Yep, which isn't very friendly for humans.
No.
So we have the domain name system, DNS. Think of it as the internet's phone book. It translates those number strings into names we recognize, like www.usatoday.com.
Much easier to remember.
Way easier. And while nobody owns the whole internet,
Right, you said that.
there are organizations that help coordinate things. Groups like the Internet Architecture Board, IAB, ICANN for domain names, the World Wide Web Consortium, W3C for web standards. It's a global cooperative effort, really.
A collaboration. Okay. What's next for the internet?
Well, two big things to mention. First, IPv6.
Internet Protocol version 6.
Right. The old system, IPv4, was running out of addresses because of, well, all the devices connecting.
Billions and billions.
Exactly. IPv6 provides a vastly, vastly larger pool of addresses, essential for the future. And then there's Internet 2.
Internet 2. Like a sequel.
Sort of. It's actually a consortium mainly led by universities and research institutions. They're building and using super high-performance networks to experiment with next-generation internet technologies and applications.
Like a test bed for the future.
Precisely. They focus on advancing how we use the internet in ways that'll ultimately enhance our lives. The cool new stuff developed there often trickles down to the regular internet eventually.
Interesting. Like an R&D lab for the internet. Okay, so we have the structure, the addresses. What about the actual services and tools we use every day?
Right, let's talk applications. Email is still a workhorse, isn't it?
Definitely. Especially attaching files, collaborating with people anywhere.
Invaluable for remote work, for global teams, but
spam. And just the sheer volume, right?
oh yeah. Spam is annoying, but even legitimate email overload is a real problem. Information fatigue. It's actually led some companies to try things like no email Fridays.
Really? To force people to talk or focus?
Kind of. To reclaim focus, reduce that constant barrage. It shows the tension between being always connected and actually being productive. Chat and instant messaging have definitely stepped in as quicker, maybe more focused alternatives for some things.
And what about voice? Voice over IP, Go IP.
Yes. Services like Skype, Zoom, Google Meet. They've gotten really good, making calls over the internet often super cheap or free.
That's got to be worrying for traditional phone companies.
It's a massive disruption, yeah. They've had to adapt significantly.
And for businesses, VoIP isn't just about saving money on calls, is it?
Not at all. The benefits go much deeper. When choosing a system, businesses need to look at features, pricing, sure, but also how it helps efficiency.
Like remote work.
Exactly. A good VoIP system makes it seamless for employees to connect and work from anywhere. Plus, businesses can often outsource the management of the complex phone system to the VoIP provider, freeing up their own IT folks for other strategic things.
That makes sense. So the ultimate goal seems to be integrating everything, right? Unified communications.
That's the dream, yeah. Merging email, phone, video conferencing, instant messaging, all into one single platform you can access from anywhere.
Like the Cisco example in the source.
Right. Systems like that aim to boost productivity by making communication seamless, connecting voice, video, messaging, even integrating with other business apps. It's about a holistic experience.
And related to secure connections for businesses.
Yeah.
Virtual private networks, VPNs.
Briefly, yes. VPNs are a really important tool to create a secure, encrypted tunnel over the public internet.
So it's like a private line, but cheaper.
Essentially, yes. It's a cost-effective way for businesses to securely connect their employees, customers, suppliers, their whole ecosystem, protecting the data as it travels.
Okay, shifting gears slightly. Let's talk about the World Wide Web itself, and then the wireless revolution. The web. It's hard to imagine life without it.
Isn't it? Started with Tim Berners-Lee's software back in '89, then graphical browsers like Netscape in '93 really opened it up to everyone.
And now it's just this vast repository of everything.
Constantly growing, constantly changing, and it runs on the Hypertext Transfer Protocol, HTTP.
And HTTPS for secure stuff like banking.
Exactly. That S means secure. And it's good to remember the difference between a website, the main place, like a company's central site, and the individual web pages within it.
Stored on web servers.
Right. Often run by web hosting companies.
So with all this information,
Yeah.
how do we open Search engines.
Are guides to the chaos.
Hmm.
Google, Bing, DuckDuckGo. They use software crawlers or spiders to constantly explore the web, analyze the content, and build massive indexes.
So we can find what we need. And mobile search is huge now.
Oh, absolutely. Checking prices in a store, finding a restaurant nearby, all on our phones.
But is it always mobile first?
That's a really interesting point from the source material. There's this mantra, mobile first, design everything for the phone.
Yeah, you hear that a lot.
But the reality is more nuanced. It's often a multi-channel majority. People might use their phones for quick lookups or social media, sure. But for deeper research, comparing products, actually buying something complex,
They might switch to a tablet or desktop.
often yes. So businesses need to think strategically about designing for all the ways users interact, not just mobile. It's a more complex picture.
That makes sense. And that ties into search engine optimization, SEO, getting your site ranked higher.
Exactly. SEO is the whole field dedicated to making websites more visible to search engines. And the future is moving towards semantic search engines, trying to understand the meaning and intent behind our queries, not just matching keywords.
Getting smarter. Okay, besides searching, how do we share information online?
Lots of ways now. RSS feeds still exist for subscribing to updates, Twitter for microblogging, short bursts of info, and wikis.
Wikis are interesting, not just Wikipedia, right?
No, wikis are incredibly powerful for collaboration within teams or companies. The source uses a great example, planning an ad campaign.
Instead of endless email chains.
Exactly. Instead of like 83 confusing emails, the team uses a wiki. Everyone posts ideas, edits contributions, shares files, all in one central, organized, searchable place.
Yeah.
Much more efficient for creative work.
Streamlines everything. What about social networking?
Well, that's exploded, hasn't it? From, MySpace and early Facebook for personal connections
Right.
to this massive multi-billion-dollar industry that big companies like IBM, Ford, Coca-Cola fully embrace for business.
So what are the pros and cons for businesses using social media?
The pros are potentially huge. Lower marketing costs, direct customer engagement, increased sales, brand building. But
There's always a but.
there is. It needs a real strategy. You can't just dip your toe in. It needs constant monitoring daily, really. And you have to be aware of the risks. Negative comments going viral, managing reputation, even security risks like account hacking.
So powerful, but needs careful handling.
Very careful.
Looking ahead, the future web. What does that look like?
One big trend is definitely visual content. Think Pinterest, Instagram. Businesses are finding these incredibly effective for engagement.
More pictures, less text.
In many cases, yeah. And all this content, visual and otherwise, feeds into big data, which leads us to the Internet of Things, or IoT.
IoT, we hear this constantly. What is it, really?
It's more than just smart thermostats or fridges. It's this whole growing ecosystem of interconnected things, devices, objects, sensors, all communicating over the internet.
It feels like it's just getting started.
It's definitely, as the source says, just in its adolescence. But the predictions are staggering, a multi-trillion-dollar market very soon.
Wow.
Kevin Ashton, who's often credited with coining the term, said something powerful. The Internet of Things has the potential to change the world just as the Internet did, maybe even more so.
That's a bold statement.
It is, and we're already seeing practical strategic uses, like smart waste management, sensors in bins telling collection trucks the optimal routes. Saves fuel, time, money, helps the environment. It's changing industries from the ground up.
Okay, that connects perfectly to the broader wireless revolution.
Right. The basic idea is simple. If you can digitize it, you can probably send it wirelessly.
Which leads to smartphones everywhere.
Yeah.
With GPS, location services.
Instant maps, finding nearby businesses, getting personalized offers, all in our pocket.
So underpinning this, we have cellular systems.
Yeah, the networks our phones use, they're different standards globally. GSM is big in Europe and Asia. CDMA was historically strong in the US, though that's changing.
We've gone through generations, right? 3G, 4G.
Exactly. 3G brought us basic mobile broadband. 4G made it much faster, more reliable, the current standard, really. And now 5G is rolling out.
What's the big deal with 5G? Just faster downloads?
It's much more than that. Yes, it's faster, but it also handles way more connected devices simultaneously and has incredibly low latency, meaning almost zero delay.
Why is low latency important?
Think self-driving cars needing instant communication, smart cities coordinating traffic lights in real time, advanced robotics in factories. 5G is the foundation for a lot of that future tech.
Okay. What about wireless networks for computers, not just phones?
Right. Bluetooth is one we use all the time. It creates small personal area networks, PANs, connecting things close by headphones, keyboards, speakers.
And it's getting more accurate.
Yeah, the source mentions a new direction-finding feature that improves location tracking from meters down to centimeters, opens up possibilities for precise control in smart homes, cars.
Interesting. And then there's Wi-Fi.
The workhorse for homes and offices, right.
Yeah.
Technically, the 802.11 standard lets multiple devices share one internet connection or printer without running cables everywhere. Huge cost saver.
And Wi-Fi hotspots are everywhere in public. Cafes, airports.
Super convenient. But big security warning here.
They're risky.
Can be very risky. Public Wi-Fi often lacks strong security. Your data could potentially be snooped on. Plus, they can suffer from interference, slowing things down. Businesses and individuals need to be cautious. Use VPNs on public Wi-Fi.
Good advice. What about WiMAX? Do we still hear about that?
Less so now, but it was important. WiMAX aimed to provide wireless broadband over larger areas than Wi-Fi, like whole towns. It kind of paved the way for the wider coverage we now get with advanced cellular like 4G and 5G.
Okay, now for a really powerful duo, RFID and NFC.
Transformative technologies, these two, especially RFID.
Radio frequency identification. How does that work?
Think tiny microchips with antennas. They can be stuck on products, pallets, even embedded in things like the NFL player example, tracking movement. They transmit data wirelessly via radio waves.
How are they better than old barcodes?
Several key ways. You can write more data to an RFID tag. You get data in real time. They can trigger other actions automatically when read. And big one, they don't need direct line of sight like a barcode scanner does.
So you could read a whole pallet of goods instantly.
Exactly. Huge for supply chains. The source mentions a railroad using $40 tags on freight cars and getting a massive ROI just from better tracking and utilization.
Wow, okay. And NFC.
Near field communication. It's a subset of RFID, works over very short distances like inches.
Like tapping your phone to pay.
That's the most common use, yeah. Apple Pay, Google Pay, quick, convenient wireless transactions.
Got it. And one more. Wireless sensor networks, WSNs.
Right. These are networks of small, often low-power sensors spread out to monitor environmental conditions, industrial processes, building temperatures.
And the benefit is flexibility.
Huge flexibility and cost savings. Need to add monitoring to a new part of a factory. No need to rip open walls to run wires. Just add another wireless sensor node to the network. Much easier, less disruptive.
Okay, wow. What an incredible journey we've taken. From the basic bits and pieces of a network
NIC's routers.
to the magic of packet switching and TCP/IP.
Absolutely crucial stuff.
To the vastness of the internet, the explosion of the web, and this whole wireless world we now live in, capped off by the Internet of Things.
It's a lot to cover, but it's all interconnected.
It really is.
And, understanding these concepts, it isn't just for tech geeks. It's absolutely essential now for anyone going into information systems, IT service management, even broader business roles.
Why that?
Because roles like the automotive digital advisor mentioned in the source, or supply chain analysts using RFID data, they need this knowledge. These systems aren't just background plumbing anymore. They are strategic tools.
Tools that drive the business.
Exactly. They enable new ways of working. They foster innovation. They create massive competitive advantages if used right.
So, thinking about all this, the convergence, the IoT expansion, here's a final thought for you, our listener. Given this breakneck pace of change, how do you see your role? How can you harness these interconnected systems, especially as potentially every appliance becomes internet-enabled to create value, solve tough business problems, and gain that competitive edge?
It's a big question. Keep exploring these ideas. Keep asking questions. Think critically about how this technology is reshaping everything around us. There's always more to learn and definitely more problems out there waiting for smart solutions using these powerful information systems.